this is the icon, Web Solutions IR.
Okay, got it.
Double click.
Over here.
Oh, you know what? Are we on right now?
It's on, but I
So the
think
green button
Okay,
showing
gotcha.
that it's on.
so we make a visualization for this because I think the power went off and come back again sometime during this week.
Sure.
So we just
Press OK. Admin is the username, no password. That's the default. You guys can make more usernames, but unless it's very proprietary data, it's normally not necessary. Okay, so here are the modules that you can open. Post run is for after you acquire data. If you want to process it differently, you can have you acquire raw data with certain parameters, but then you can process that data in like at the post run setting and look at it different ways or set other parameters to it to say find a peak that was too small in the original parameters, things like that. Spectrum is the main module that people will use. It's the quick, you get in there, load your sample, press measure, and you get a result. Quantitation is if you have a way to, if you have standards, and you can make the calibration curve based off of that, and then use those for your samples. So in your case, I'm not sure if this would be applicable with the films, versus like if it was just a cuvette or something like that maybe. Let's see. And then photometric is you are taking, it's kind of like spectrum, but you're doing multiple wavelengths, so you get several places to pick from. So let's just start with spectrum. That is the main one, most commonly used. Also, back at the instrument, this is showing that the humidity, or the dehumidifier is running to keep the internals dry so there's no corrosion. That's very important. It should be always running. If it's plugged in, so if the instrument's plugged in, then the dehumidifier will be running. Alright, so this is the main interface that you're going to see when you open the software. I want to draw your attention to this blue bar across the top. So you're going to have measurement and view. These are the two views that you swap between. But before we can do any of that, what is that initialization? Alright, so in instrument, there's two things you gotta do. You have to connect and you have to initialize. So, I'm going to connect first. After we're connected, we can initialize. Retry initialization. So here's another menu that you want to pay attention to. Here. So file and edit are going to be self-explanatory. You can open your files, you can open your catalog, and edit is the simple edit commands. View is important. So if you click something, for example, this is the tree view. It's looking at all where your files are stored. So as you open files, that's where they'll appear, and they'll be in a tree like level 1, and then indented to like level 2, level 3. So if you click it, if it's already showing and you click it, it will hide it. Oh, sorry. Or maybe it doesn't want to hide it like that. Status report. So, for example, status report should be showing down here, and then it goes away. Now it comes back. Measurements, so you see the check mark on the side. Unclick it, it gets rid of all these buttons up here. But typically, I like to keep everything available, but it is a kind of a small screen, so if you need more space to see what your files look like, you can kind of get rid of some of the extra stuff at that time. So you can move the windows with when you click a double arrow, little stuff like that. Alright, so here we go. So yeah, so it's right now there's no tree view. This is the measurement area, not measurement, sorry, the status report being expanded to fill this whole area. So be aware of that. So the tree view this is where your files will go. So, for example, we want to open a file. We want to open to a file you've run.
No, actually, we can use this tutorial.
Sure. Yeah.
Yeah, we can use any one of them.
Yep. All right. So it opened our spectra, and then it also opened the tree here. So you can see here. All right. You can see it has your active data, and then under that is the active data file itself. We opened another file. So you can see how it makes a tree for each one. You can look at the properties. History, all of those, and history for this. Okay, not much, looks like some timestamp data and stuff like that. Alright. So, and then across the top over here, you can see which file you're using. Swap between the two. You can also do where's the overlay? You can do some manipulations here. So if you zoom in, you'll want to use full view. Right now it doesn't do anything, but if you click and drag, it'll zoom in. So you have to click and drag and then click again. And so it shows here's your full spectrum here, and this is the zoomed in portion of it. And if you were to right click, you can go to full view, and that brings you back out. I guess if you wanted to, if you were doing it step by step, and so you right click, drag, click again. You said, oh, that section not enough. Right click, do it again. Oh, I want more, do it again. Now if you right click and do last view, it'll zoom out just enough. So you can kind of control how you're zooming. Let's see, what else? Of course, your scale is down here with your water peaks and stuff would be like over here. Or OH peak, I guess that would be. Let's see, they should have an overlay feature. Okay, so overview looks like, oh, overview is going to be that top part, that's what they're calling it. So this is the overview, meaning the whole spectra, and then you're zooming in on the portion of it. Let's see, so right now this is the view window we're on. And if we wanted to take another measurement, we would have to click back to measurement. It takes us back to the measurement side. So, did you have...
It's send as a send.
Is it already?
Yes,
Okay. So let's, here, sorry, you take it out. Let's run a background check first. Or not the check, just run a background scan. BKG is for background. And basically you want to have like a starting point. So you run your background scan to see if there's any kind of noise that's consistent. And then when you put yours in, it'll subtract that out.
So may I ask if there's any noise after run a background check, we find any noise, so it does a button that will reset everything so that it goes to 0?
So you're basically subtracting. You're going to subtract the background spectrum from yours.
Okay. So, okay.
That's how you.
You don't need it 0, just the subtract, then you got what you need to measure.
So I guess I should have looked over here to ensure that. I'm going to actually cancel real quick. Before we do that, take a look at the. I want to zoom in on this guy. There's like the parameters section.
Okay.
So here's like your sample info up here, and then here's your parameters. So this is the type of transformation. The hap cancel is the most commonly used. Basically, that's what you call it, mathematical processing. And we're in transmittance mode, which is what we want, but there are other modes you can try, but this is the most commonly used, and probably there's most data on this as well, like if you're comparing to other stuff. Let's see. So scans. The more scans you do, the better your resolution. The longer it'll take. And you can also, there's a direct resolution here, and this is more of a, I don't know if you want to call it slit width, but like amount of light going. That's going to be amount of signal going out. I guess it's,
That value is for the signal. That what's the unit?
So, what's the unit over here? Press F1. Oops, function F1. Okay, never mind. The contextual help is only on the GC software. Yeah, I actually don't know the value of the resolution. I'm not sure if it might be dimensionless, or it could be maybe nanometers of like a slit width. You might want to pause the video for a moment. I'm not sure anything useful.
Maybe we can come back.
On for like almost an hour. If you want an excellent
It's
version.
around for a long time. So it's,
Okay, great. Excellent.
Since the installation 2 weeks ago.
Okay. But yeah, so that's just good to know. You know, it takes some time for the
Machine to warm up.
for it to stabilize. Yeah,
Okay.
yeah.
But is it advisable that it is to be running packages? Or we
It should be. It should be plugged in just for this feature, just for the dehumidifying.
Mm.
Okay, so sample is out of the compartment, which is good, and we can run a background scan. Number of scans, we'll go with 10 scans. It should be very quick. And then this, of course, is the range. We're going from 4,700 to 340.
Yeah. How do we determine 10 or 5? 5 scans or 10 scans?
It's your preference. If you think the data looks good enough, you can do that. If it's
It's based on the data you have. If you feel the data is not good enough, then I just increase 10 or 20 until I get a satisfied one.
yeah, it's just a trading between
Time and the quality.
Time and quality. Exactly. Okay, we'll go and have the background scan. For the sample compartment, background scan. Okay, it just means if there's a sample, take it out. Now it's going to set the air pressure.
For this question, the data speed is coming, it's its own because it's all specific. So the data take the not the one depending on that. Only depending on the effort coming from this. It's affected and the detector will be missed this field. So the thing will be shown, expected to be like, so that's what it's
So here's the time remaining. Down to 0. Should be, there we go. So pretty fast.
That's really fast.
But maybe could be a little cleaner. Some of these smaller peaks seem like they're not very well defined. So, for example, if we were to try, sorry, that was it preparing, and then once we started seeing it, that was the first scan starting.
What is this material?
This is nothing.
Without a sample.
Yeah.
is the air?
The air, it's also, it has to go through the window, so it's going to be something on the window.
Oh, okay.
And this is what, 2,400? Probably like a CH stretch or something like that. I'm rusty on the wave numbers and what correlates to what. But is it internet connected? Is there internet? No.
Yes.
Because there is some great resources. I'm sure there's just some. Yeah, so there's some simple ones. And I've seen some really, really nice ones that go through almost everything, and they talk about the shifts based upon the other groups that are around it, or if there's conjugation, the alternating double bonds, things like that. So it looks like between 25 and 2000 is these 4 types. CC triple bond or CN. They seem pretty intense though. Where's the CHs? This is that more up here. So, I mean, there's resources out there. Where are we at? Where's this one? 2400. So, anyways, we're looking at a background scan, so it could be.
If we analyze this data, we can get that.
Yeah.
Yeah.
Or right. If you're looking at libraries, yeah.
Okay.
Yeah.
So can we apply the library to here so that we can directly compare what we have measured with the library plot? Is there a function to do that?
Yeah, well, I mean, not the background scan, but
Oh,
yes, in
okay.
general, yes. So sorry, I'm going to close these. These are just random files. So close. Okay, so if you're done using a file, right click, close, and then see how that tab is now gone here. Click, close. So now our background is all we have. Good. So right now we're in view mode. It seems almost counterintuitive that it looks like it's almost grayed out, but you can think about it like that button is pressed in.
Mm-hmm.
So if we want to go back to measurement mode, click measurement. Okay. Do you want to name this sample anything specific?
Just background scan.
File name. See if we have an auto file name.
Yeah, we'll just test background or something.
Same, right? Just a bunch of numbers. It's probably a date or timestamp somewhere in there. All right. So we have two other modes. So there's a background scan, and then we can either do a sample scan, which is a single scan, or if you had something that you think is changing over time, you could do monitoring, which is kind of cool. I guess it's more for reactions and stuff like that.
Yeah.
Maybe, well, not an epoxy, you know, harden very quickly, but
Or your phase change material.
No, not that way, because the phase change takes place at a specific temperature. What
Yeah.
you're saying that you just monitor the reaction going through part of time.
But it could, it's really any changing parameter. You're monitoring it, so you're looking
Yeah.
at it over time. So if there was,
It's a real-time monitoring.
Any reaction
Yeah,
is
yeah.
happening, then
Yeah.
Yes.
right, so if you have the interviewing sphere and you're heating it through
Yeah.
a certain ramp, yeah,
So
you
you can
see it.
observe that chemical reaction.
Makes sense.
Like-
Right. So,
but then how many
well, if it's monitoring, it's just going to be looking at it, and you could take a scan at any time.
Oh, like I take screenshot
Yeah.
for the
Yeah.
time.
Yeah, it'll save it.
and we have the control of how much time
Yeah, that's the number of scans and resolution. Yeah, so if we were to click monitor, so it's monitoring it.
That way I can just watch and then switch the screen. Is this around my head?
Oh, there's the energy that's transmitted. Is it changing the mode? It's not transmitting now. So I think it's just gonna keep doing this. It's taking, blinking, I think it's just taking a photo of it.
Yeah, that's a beautiful function.
I should have done that. I was just gonna send it to Kevin so that he can upload to the YouTube.
Oh, you know what? Let's do one more thing to see. It didn't prompt us to save it, so I'm wondering if that's. So it's going through scans. However, is it saving? So it looks like it has to complete something. It wants to do a full. You want to see the monitoring sequence. Alright, so You want to go ahead, so we have our background scan. You want to go ahead and put the sample. So, scan, sample scanner. Again, it's only going to take a few moments. It's like 18 seconds of rest time.
When I do the sample scan, I don't want to worry about the background because it's already making the subtraction already on the same flight. So
Yes.
once I get up to flight from here, it should be matching my sample.
Correct.
Wow, it's fast.
Looks like it's like cutting off this a little bit. Yeah, I think that's all there is over there, though. In terms of, if you go to measurement, you still see all the parameters. So here, it keeps going to view because we have this check mark switch to view after scanning. So typically you'd want to keep that because you'd want it to move to the view mode. Okay, so let's see, what do we have? We can do, these are some different features. Well, in this case, it's just the search feature. If you're in the view mode, you can get more features. Here's where the other feature is. So the data processing. Lots of different processes you can do. Obviously, you only do the ones that make sense.
Can you check on thickness?
Looks like it. I think there's a special attachment for that, so I'm not sure if it's going to work for this.
Okay, just as
Film calculator, here is that. Film thickness calculation of the background file. It's not gonna. It's kind of a it's nonsense.
Is that a warning?
128 microns.
that? Okay, so
Yeah.
oh, great.
No, it says the background. It says the background. Yes.
I think it might be because I didn't change the file name and it applied the background to the sample afterward.
So maybe the sequence is here.
Does it say it has some information?
It's maybe the file.
Yeah.
What is the sample material? Justin, do you know what is the sample?
I think it might be a calibration one, but I'm not sure what
Yeah, I
the
think
sample
it's,
is.
Look for the sample. So you look for the sample.
Mohammed, what sample is it?
Sorry.
Sorry.
This is the
Polystyrene?
reference sample.
Oh, FM.
Polystyrene film.
oh,
Okay.
polymer, something like polypropylene.
It's just
Polystyrene.
Okay, polyester.
Polystyrene, yeah.
polystyrene.
So the calibration.
Yeah. So
Yeah, that's
we have our file. We click the search button, and now these are the libraries it's searching. So food additives, ATR inorganic 2, ATR organic 2, ATR polymer 2, IRs, agrochemicals. There's a bunch of them. I guess I'm gonna have to read them all off.
Okay.
And so you can search from all of them, or you can select which ones you want to search from. And so, for example, information. So right, so you can see the information of each library. In this case, food additives. Food additives. In the spectra, there's 63 spectra in that library. Okay, and here's the properties of the library. It's going 600 to 4,000. Giving you a little bit of basically just how the data for this library was acquired. These are the parameters. The main parameters. Here you can adjust what you're going to see as your output. So this is saying, here, if we go to the view window, it should show now. something's not showing right now. Or sorry, I just need to do spectrum search. I need to actually perform the search. Right now, I'm asking it to give me 20 hits, so 20 options to choose from. And this is a quality number out of 1,000. So in this case, they don't really need to be that close. 250 out of 1,000, 25%, similar. It's kind of like a dimensionless. If you went to 1,000 out of 1,000, it would have to be a perfect match for it to show. So that's what minimum quality metric means. So let's just go ahead and spectrum search. Okay. So we asked for 20 hits, so we have 20 lines. This is the worst match. Over here is the top one is the best match, and then here's your score. So 897 is pretty good.
Yeah,
it's a really good match actually. Which makes sense. It's a reference standard, so hopefully it will be a good match.
This is material matches and it's the same thing.
Yep. Polystyrene 2. It's like so since we're looking at all, how many libraries is this? We're looking at all libraries. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We're looking at all 13 libraries. So we're going to see multiple hits of polystyrene because multiple libraries contain
different.
Well,
A little difference.
Well, maybe a little, yeah, slightly different because different scans. But overall, the first
The names
5,
are different,
6.
yeah.
The names are slightly different, just I guess how.
Depending on the library.
Yeah, exactly. But mostly it's the differences are, how do you call it, like syntax. It's polystyrene, and one might just say polystyrene, one it's polystyrene with the parentheses PS. That just means polystyrene. This might be a specific style, kind of, or manufacturer during sample.
So this result will directly tell you what material it is, no matter what you throw inside.
If the material is contained in the libraries.
Okay, then that's very useful. What?
If you're making a new material, I mean, that's by definition it won't be in a library.
Okay.
If it's new.
Yeah.
How do we guess it?
How do you guess it?
Yeah. If you are like say making a new material.
If you're making new material, you're going to have to actually learn like the bands of IR. So like you have to do what I was doing before, like on the internet where it's showing. You have to like learn the theory. So for example, it says, this is an NH band here. This is C double bond C. So when you piece all that information together.
Chemistry.
Yeah. A lot of times it's going to be hard to characterize a material with just IR. So a lot of times people will do IR plus maybe NMR or IR with maybe there's
Ramen.
Ramen, yeah. That's actually a very good compliment.
So you say it is difficult if there's, for example, Mohammed's project, if there's a vanadium oxide and different types of vanadium oxide, I mean V2O5. So when we are running through that sample, they have everything of those inside that sample, and then we are running through. It might have difficulty to recognize those 3 different materials.
It may. So the other thing is, you can still use these libraries, but you just might expect a lower match percentage if it's a new material.
Okay.
So you could try to find a material that's similar to it, and then maybe it shares some of these bands, but maybe it's shifted, or maybe there's an additional band. If it's if it's a mix of materials.
Yeah. But it will, at the end, it will tell you all the materials inside. For a specific sample. Let's say there are 3 layers of material which have different materials.
That is not with the tracer. If it has different layers, we do have it's called the AIM site. It's a microscope that is able to look through its different layers. Like if you had a cell phone, it would look at like the different layers of the iPhone glass or something. Some are like pressure sensitive and some different properties for different layers. So that is a different instrument. It is something that we can pair with this. It's normally sold as together.
Because now we're dealing with only one material. So
But later on.
if If it's
So
getting more.
what is the goal here? That you're trying to stack layers of different material. Are you making solar cells?
He already has the different layers of
Okay.
materials. So
So what I'm showing is that I have this silicon wafer here. It's a bare silicon wafer. So that's why I'm trying to put it here. I have a little bit of silicon wafer.
So you can subtract it out so you can see the other layers. That's a good strategy.
Oh, you can subtract. Okay.
Yeah, so if you have 3 layers on one, but then you are able to take measurements of
For each
the
one,
2 single
yes,
layers.
Yes, so I start with one layer, then add another layer, and so
Oh.
add another layer, and then
Okay.
again so that's what I'm
Yeah, that's a good strategy.
But when I put the silicon wafer inside, actually it didn't work. It didn't give me silicon. That's why I'm.
It didn't give you some.
Yes,
Okay.
something like that.
You mean like it didn't find it here? Right? Like it didn't give you a match.
we need
It
that.
should be here because it's a silicon. So silicon wafer, I think it's some kind of common material being used, right?
I would think so.
But anyway, we can try
But
this.
yeah,
Where
maybe.
was the peak?
Yeah, let's see.
Yeah,
I want to
have
know
it.
how many. What's the?
It's called,
But it was matching with the silicon.
it's a different material. There's not much inside.
Just leave an error. Maximum hits must be between 1,000. Okay, so you can make 1,000 hits is your max. I don't recommend it. Probably too many, but just out of curiosity. And the quality, I believe, also 1,000. So I do spectrum search. The quality must be between 0 and 1,000. Yeah. So let's say 400. Spectrum search. I want to see. Well, I guess I won't see the silicone because we're not running it right now. Yeah, do you want to try putting that in? So you can also do peak search. So if you don't want to do the full spectrum, you can. This is, I think, closer to what you were thinking. Is that if some of the different than if you're just doing layers, this could work. But I was thinking when you were saying making an entirely new singular material that's like half one layer and half the other layer, but mixed together.
It's a composite.
If it was-
Uniformly
right, yeah.
mixed out.
If it was something like that, you could look for specific peaks. I mean, I guess you can do it either way. Let's see. And then you have to define your ranges. So, like, let's just say. Sure, we can just do it here,
Just for the piece, it's very specific range.
yeah. Selected. Aha. I had to click the range before to let me. Alright, so then, for example, look at it's a pretty big range. Your range. What we just do. Even that seems big. That's okay. Okay. Why? Oh, okay, so if you don't directly click select range right beforehand, it zooms it instead, so. Which is good, I guess. It's good to where you need to be. Alright, so this we're looking at right here. So now let's run spectrum search. Running for labels. Let's go with some data. Could be that parts of so if you do the range, I think it's only matching that portion of it. If you wanted to, let's see, I want to look up peak search real quick. Noise ratio. Parameters area. So. Oh, interesting. Okay, so it looks like these. So like this polystyrene was made with a different accessory. That's why this Durasample IR is a series. So it's like we have the IR, the standard of that polystyrene just with the normal IR, and then if there's this accessory, like for example, if we took this polystyrene and had the ATR pressed down on it, it would give a very similar spectrum, but it would be associated with a different library because it's like the data was acquired in a different way, or with a different accessory. So that's kind of can explain why there's all those different hits of the same polystyrene. I'm not seeing that peak search part, so I'm gonna have to play around with that. Okay, so did you want to run the silica again? Let's see.
I want to ask you about something.
Yeah.
So if you go to the measurements and you try to change the range of the scan, it didn't allow me to do it. So I just want to make the scan maybe so it's something like that. And I try it and try to make the measurements.
You do the sample scan.
You see? Something like that.
Now the available background matches the current scan parameters. So it just means that you're trying to measure with different parameters than your background scan, so you just need to do your background scan again before you.
So how do you determine the range of the wavelengths?
Down here is where you would select your range, and it's just what I mean. You run your sample the first time with the full range, like whatever it looks like 2047 is the large, high end in this case.
And then you narrow it down to improve the measurement efficiency.
Right, because so you can have more scans in the same amount of time because you're looking at a smaller.
Because you don't want to run through all those wavelengths. Gotcha.
Exactly. So let's see. We should look into the parameters more. So we do have the data tab. We've done that. Then there's the instrument tab. So you guys mostly just going to use internal. Detector. If you had additional detectors, like when you install the ISR, you'll be able to select that. Mirror speed. This is how fast the mirror is moving as it goes through the wavelengths. And atmosphere correction.
I don't know why the mirror is moving.
So, see the components on the inside. Should be a good diagram. Go, yeah, principles. Okay, so this is what you're seeing on the inside. Here's your source. Your first mirror. Over here's a moving mirror. And here's the beam splitter. So as it crosses here, the beam splits. And you're seeing one versus another on the detector. This is like your reference is being seen, and this is the difference from that. Yeah, I'm not a.
Yeah, I mean that's the fundamental physics behind this FTIR. Right? Where is this
This
doesn't
is
matter.
in this is in the manual.
Where is the sample in the
Oh, where's the sample? Sorry. The sample is going to be here, I want to say.
After the splitter?
This is before. That's a good question. Yeah, where is the sample?
Maybe it's just a schematic, but for the real setup, it's sitting in the middle.
Yeah,
So I think it should be after.
yeah. I mean, in the end, the people who design the instrument, they put the place where you put the sample in the right place, so you don't really need to worry about where it is in the diagram.
Okay. Yeah, it's just drop the samples in the place.
So now I'm going to now consider the lever of this.
Yeah, perfect.
And actually, you can try the ATR with the reference sample because the ATR is not working. I tried to put the reference sample in the ATR, but it didn't give me the sample file. Different
Okay.
file. So,
Do you want to do yours first or you want to do
no,
first?
just you can do the ATR while I'm mounting and it takes some time to mount the sample.
Oh, I see.
Yes, so I'm going to take this.
But you're gonna take that out and like mount it. Sorry.
Yeah, you can use it FTIR with the reference sample, and I'm going to mount the circle info and come back to it. Okay?
You just need to remove the substrate. This one is just a very simple substrate support to hold that.
Yes.
And
I
then
don't
that
know,
one-
actually, I tried to find something to hold the circle, the one silicon wafer, but it's not working properly. You see, when I put the silicon wafer, it just dropped down, so I have to put some tape. So I need to have another holder. I don't know, so I'm going to.
I
just
think
mount
simplest way just use a tape too.
it. But
Just
it takes a
tape
long
to-
time, so I'll just put one sample and use the tape, then remove the tape, put another sample. It should
Yeah.
be something to put it.
But anyway, the infrared only penetrate through this circular area.
You
Sorry,
see
I
the
shouldn't
infrared,
touch it.
if you see this is infrared. Okay, so just have a look.
Yeah.
In my hand.
Oh,
So
okay.
simply the infrared goes through this
Center. It's not even covering that large area. Only a center,
No,
a very
it's
small
only-
point.
It's only center because it should be transmitted. It should go through this way and come back here to the detector.
Yeah, makes sense.
So I put my cycle wafer here on this side.
Yeah, no problem.
I take this.
Amount of pressure to do the same thing.
I have a question. Let's say we are measuring some liquid and it's getting dirty. How are you supposed to clean it? Is it easy to clean?
Well, first I would just wipe with a good wipe and then see if the background is good. But if not, a tiny bit of isopropyl, something like this.
I kind of use something like this. We had a different brand, old one, for the powder.
Oh, okay. Oh, you can also put powder here.
Yes. Now, what I would not do is I would not take a metal utensil and scrape across the crystal.
Yeah.
Yeah.
Believe me, I didn't think I would have to say it either.
No.
It's gonna break that
Yeah.
setup.
So, but I have. It doesn't say this.
So now you're filming preparation of sample.
Yeah. So sample preparation. So if our sample doesn't stick or it doesn't like stay stable on it, what type of tape is that?
It's the masking tape we're using during the sputtering.
Oh,
So
okay.
it's a special kind of tape that can actually resist till 200 degrees.
Interesting.
A movie star, great scientist, not a movie star. So just the computer is great. So you're going to go into post run. And it's going to bring you, everything is going to be blank. The first thing that you need to do is actually open the data files that you actually want to add to the library. So I'm just going to add some random things in. You can try that too. Just actually get an actual file that looks like a file. Cool. So then we're going to go to library, and with this small drop down, actually let's just go ahead and hit library. So then it's going to take us to our library window. We're going to click the library drop down, and we're going to hit new. So then it's going to ask for a file name, so we can just say test. It's going to show you the path where it's going. You can feel free to change that. I suggest leaving it here because if you put it somewhere else, you're going to have to do some hard work to try to find out in the search function of Spectrum how to actually search within that library. So please leave that piece alone. The title, we'll just call this training. And then copyrights, if you have any copyrights that you want to add, if this is sensitive information, feel free to do that as well. In these options, you can set a minimum or a maximum of what you actually want to take out from the spectra that you're adding to put into that library. So if you have some particular wavelengths that you want to look at, you can edit that here. So we're just going to say okay. And so now we've created a library. And the next thing that we're going to do is drag and drop that over.
So, comment on that, choosing that range. You can have your same data file duplicated or run again and with a different range.
Or it would let me drag and drop, but I don't know why it didn't let me drag and drop this time. So what you're going to do, so remember the first thing we want to do is go ahead and open those data files. You're going to right click on those data files and you're just going to select insert into library. But that doesn't have a wave number, it's a background. Let's see if this is not a background. That's also a background. So I'll open another one.
Sorry, we haven't scanned it.
Oh, no, you're fine. So we're going to right click. Let's insert that into a background too. So you can see these windows are clickable. So say that you want to edit it, you can also edit those names and change it to anything that you like. So say that you have aluminum layer A versus aluminum layer B, and you can change the naming to tell the difference. And so again, all of that is saved. So if we go back in, Spectra. It's not gonna let me open it. Let's open another window. Our software is really it really hates being open in a lot of different windows. So if you get it's open somewhere else, just be sure to save everything. So I've saved this. We just have a really quick library here with those two compounds in. So I'm just going to go back to Spectrum just to show you. We're just going to add our test library. So again, it doesn't automatically populate here. So just remember you have to go in and add that library back in. So I'm just going to go into test, open, training. Let's click for SCP. And let's search. Cool. And it gave us our search result from our library that that polystyrene that we took from our library. So
Can you get the libraries from external sources?
absolutely.
It has to be in what format?
Let's see.
Is there a restriction for the format? Sometimes
Exactly, it won't open. I want to say it's a .ipsd. Let's see.
Sometimes view file extensions.
That's it.
Right.
I don't think creative field.
Okay.
The LOOIDX files.
And this is going to be the name of the background scanner or the name of the file that's run?
Background.
So that's going to be the name of the file name. The background scan is always going to be last background.
So that's
Exactly.
is that simply per constant, right?
Yep. So say, hey, are you sure everything's empty? Yeah. And then you probably noticed, it should do it on this instrument. Does it have the warning that comes up about the light being on for the humidifier?
I think it's like at the very beginning.
Yeah, it should have this caution. So
yeah.
whenever you're going out of the software, there's a good chance that you'll see like this caution sign. Do not be afraid. It's just telling you that the light needs to be on for the instrument. This orange light needs to be on to make sure that the dehumidifier is working. Please, if that orange light is not on, call us immediately, because that means that if there's humidity getting into the instrument, it can cloud the optics.
Oh.
And so again, we can't clean the optics. We would just have to replace the entire optic. So downward light needs to stay on. So
Yeah,
that
that's
warning
like
is just
the
going to
window
tell
getting-
you.
That's like the window getting foggy. Or
Yeah.
it's actually more than that, it's the other optics inside as well. But
Because this system heavily rely on those mirrors to do the job.
Exactly.
So it's getting foggy. It's-
And once it gets cloudy, our light is now bouncing in a strange way. So
Okay.
So now we're done.
Okay.
we're done. Yep.
Okay. So simply I just go back to measurement, right?
Yep.
And I just need to do another sample. So simply just put the sample inside and hit sample stick, right?
Yep. And I like this because then we can do it on the ATR and we can do the ATR correction and compare what we get from the transmittance of the wafer, direct transmittance compared to the ATR.
So may I ask you, if you are using this ATR for measuring silicon wafer, do we simply put the silicon wafer here and we don't have to necessarily push into the small hole here, push into inside.
You want to put the wafer there, and then this has to at least make contact. But it's
That
you'll
has
have
to
more.
be coincide this small
You
hole.
will have better results
Mhm.
if you have consistent pressure.
Okay.
So as long as, I mean, test it and see if it cracks the wafer. If it cracks the wafer, then
I think it will
then-
if it will
you think it will crack the wafer?
I think it will work.
Why?
I'm not quite sure.
Is it, your,
That
is it the only
looks
wafer?
fine.
No, I have a lot of wafer.
Because we should test it.
So simply right now, sample scan, right?
Samples can yes, right.
It will not give the exact price. Yeah.
So you already did the
25
background.
microns or 50 microns.
That's a lot of noise.
They should give very similar
But
measurements.
the pressure is not same, applying on all the particles.
Then you'll have a slight difference. It'll be a slightly different spectrum, but it's still the same material.
Yeah.
So it might be like this band is just a stronger signal because it has more fine powder with a perfectly even pressure.
Okay, then, so
Oh.
I have different questions going. So first of all, why it goes to 250%? So it should be 100, should be maximum 100, right? Something here is going to very high transmittance. I'm not sure what is that.
Might be an error.
I don't know. So I
don't-
think
I
it is
don't know
better.
This is the energy level supposed
This
to
looks very
maximum
strange. Like a typical IR doesn't have this.
Yeah.
Maybe it,
These are these noise? It's just a lot of
it looks very nice.
it bumps up and down.
Yeah, I'm not surprised it looks like that. It's outrageously opaque. So,
So you think maybe we could increase the number of scans? I don't know, scans looks resolution. I don't know if it's gonna.
it would help. So increasing the number of scans. So we would have to scan it very, 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 very slowly. But
We're
even
doing
still,
nothing. We're doing 10 right now, so it's pretty low.
oh, that's very, very low. Like the
But-
average is like 45.
Yeah, so let's
Yeah.
do
But we're not
like,
supposed to have an energy intensity more than 100%, right? If there's a 250, why we're just proposing?
transmittance.
It shouldn't go beyond 100%, right?
Is it it's
I would say that's
reflective?
true.
Is that reflective? Could it be?
It is. That's what I'm thinking. Yeah, it's reflective. So I wouldn't be surprised if it's a lot of bounce
Bouncing
back that's
around.
happening. Yeah.
Is there a layer that you could put on top of it that would make it more of a map? Like less reflective?
Well, I think we should try it with the ATR because
Yeah.
I think, yeah.
Should we want to run a scan with 50 instead so
Oh,
we
for
can just see a
sure.
little bit more detail here?
If you want to
You're
try
gonna tell me I
graph
need to
graph
resave it?
later.
Yeah, I need to save over.
It's going to automatically create a new file.
Oh, yeah, auto increment.
Mm-hmm.
So as long as you have your auto checkbox auto increment, it'll add like 001 to the end of the file name, or 002 or 3.
Automatic save files.
Yeah. Yes, it's very, very helpful. You have to rename your files every time.
I'm not surprised. I wasn't expecting this to look decent. just throwing that out there.
So what samples do people normally test for? Like if they have the equipment at the like a university or something like?
Oh yeah, we ran down the list.
Oh, okay.
Everything. So people do thin films.
Right.
People do powders.
Okay.
In chemistry 101, they like doing the ATR and doing liquids. So like organic volatiles. What else have I seen? I've seen windows,
Okay.
kitchen cabinets.
Okay.
I've seen so
Interesting.
much, honestly.
Okay.
We have an accessory where you can just drop a full capsule in. So I've seen people just put full capsules in.
Oh.
Can we use ink with that because we are using ink for the city
Yeah.
building, so sometimes you need to characterize the ink itself.
I have seen people do ink. I've seen particularly people do ink with the integrating sphere. Yeah.
That could be helpful.
Exactly,
'Cause
yeah.
I'm working on some of the project is also jet printing.
Mm.
So we're dealing a lot of different inks. For example, the most typical commercial single nanoparticle ink. But we also mix with nanowires, for example, to create some extra functional devices. So we mix those inks together and deposit. But you know, in order for the publication purpose, you always need to characterize the ink it is to show to the audience, right, what it is.
No,
And
absolutely.
Then, so that's why we always need to characterize the ink material.
That makes sense. I'm pretty sure there's some application notes for it. I don't see why you can't use the integrating sphere that we're receiving from pipe. You should be able to use the integrating sphere. It's very, very sensitive. Let's see. I have a customer. I know a customer that's doing inks with the
Right, so
integrating
now
sphere. I'm going to try to pull some application notes. Would you like me to try to connect
We're
you
gonna,
with that professor? And
run
maybe
the
you
same
guys can
material
talk
on the
about
ATR.
what that looks like in terms
It's
of how to
fine.
translate. Okay. Yeah. Yeah, for
But
sure.
right now we are not a
We
project.
do have to-
because, you know, once chemical process is involved,
So this can stay
it's
attached,
complicated.
but you can't
This
close
lab,
the
you know,
ATR.
we don't have a chemical hood at this point.
Right.
So mixing new material is very challenging.
And you know what? I just noticed that you guys don't have a fume hood.
Yeah.
You were so right. Wow.
Yeah, you know, a lot of bottles and this,
Exactly.
mixing this and that.
I like the glove box though. That was pretty sweet.
You're so right. Wow. Huh. Yeah, but that's
Clean
not like
room.
a, yeah, that's like a, yeah.
I mean, I guess if
Like
you're
a
making,
BS1 cabinet, yeah. Huh.
is that's because you're making like the silicon wafers and stuff and everything?
They're doing the solar cell research.
Yeah, clean room for solar stuff.
Yeah. But it's not part of our labs.
Okay.
It's close to our professor.
Oh, okay. That's
So
really
just so you can
actually
see.
have a-
This sensor on the bottom
Okay.
is going to attach here.
Gotcha.
And
Okay.
that's how the instrument is going to knows that the ATR is the
attached.
accessory. Yep, exactly.
Absolutely.
This is a click in, I
So
assume?
for your research,
Yeah.
Okay,
yeah.
gotcha.
where do you plan on applying it? Is it kind of similar in the same fashion for NASA? Like we want to use it.
And just
to
kind of
maybe
tinkle in
for
there,
rockets or something?
wiggle a little
We
bit,
have a
make
lot
sure
of
it's in there.
application in NASA. That's a great idea.
Yeah.
So we developed a
You can
lot
see
of
it's flush,
sensors,
so
some moisture sensors,
that'll tell you it's there.
customized,
It's not
verified,
wobbling,
coffee
so it's
sensors.
good.
So we
Okay.
use
Leave it
those
open.
software sensors mounted on the space sheet to monitor moisture change, temperature change,
Background.
how does
First,
it react
first.
under a really high acceleration rate or speed?
That makes sense.
So no metal against
So we're
that.
adding the sugar to the ink as
So
a
it's
some
touching,
kind of
and then you
code
go
that
until you hear the click.
well, I guess,
So you can
alleviates
feel it.
the
Okay.
Wow.
It's
okay.
based, it
So
torque to a certain
maybe
pressure and it
now
won't go
we
any further.
Gotcha.
So
Yeah.
How much pressure
That's
that
really, really cool.
Yeah.
I can wrap my
Let's
head
say
around
it's
it.
thin
Can you
film.
send me your research?
It's a nanometer.
Yeah, yeah,
The whole, I'm just
You apply
interested.
the
Yes,
pressure,
yes. You
too
can,
much
uh,
can damage those.
there's a good question. I'm not sure what the
Oh, please.
torque
Yeah,
setting
I'm
is.
giving you guys business
And there, I
cards, so
believe
you
that,
can email address as well.
well, it's not recommended. I believe that you may be able to loosen this hex screw on top and adjust the torque. But I would,
Double check.
yeah, I would wait unless you find that it keeps cracking your wafer and then it's like necessary. Yeah. Okay, so we're gonna do.
I think the point is that you should keep going till you hear sound like something ticking. It says that it's a good contact.
Like nanometer.
Yes, it could. Yeah, it could take something. You know. Once you try to do like the same thing, the same
Yeah.
So I'm not sure that I want to
So this is the case. And here's one for you, but you know how to get in contact with me, Mohammed.
Alright, so let's do background stuff.
Here you go.
Thank you so much.
You're welcome.
Please prepare this. We're good. So we're running a background. and we kept our 50 scans, so it should be, we kept all of our parameters the same as the other, so it should be a direct, any difference that we see should be purely the way it's being acquired, you know, the straight length path, the normal setup versus the ATR. That's the only difference. So all our scans and resolution is all the same. Wavelength range, it's all the same.
Sorry, I didn't catch up. Are you measuring the silicon wafer now?
Oh, no,
Back
no.
one first.
Oh, okay.
Did that library portion make sense?
Adding a new limit.
It should be, well, we wait for this will be done in a moment, but that library portion should also be able to be found in the manual. Let's see. No, not showing you how to make library here.
What's the question? Does the crystalline structure matter? Is amorphous? Same
Let's
again.
see if it's.
It's crystalline. Same. It should be, but
On Columbia.
Technically, it should be, because I would say all of the stretches would technically be the same.
I'll see if there's a document for like a quick guide for the library, and I'll send it to you guys if I can find
Yeah,
it.
because I don't know how
I mean, it
we
seemed
would be
pretty
able to
straightforward. Maybe I'll just make
it.
it.
Like, so it should be the same. Yeah, I agree. Yeah.
Alright. Let's see. What was your question? You remember? This is the sample where you would put the window if you were changing windows.
Oh, okay.
Okay, so let's go back to our thing. We have it. So, this is, so again, it goes right to view mode because we have we have it
Take this again.
checked over here. Yep. So every time it finishes, it changes from this mode to the other. All right. So now we are ready to.
I think if anything, it'll probably be a minute difference between like the, because we're talking about cis and trans, it would have to be a minute differences between those like those alpine stretches. So
Something.
I guess I'm not even sure what this is in trans and it's.
stereochemistry. So say that we have two isomers.
Well, what are
How
they?
different would they look on the FTIR?
I see. And what are they in this case? It's just the different way this silicon is.
yeah, sometimes it can be amorphous, sometimes it can be
Let's
just
start clicking.
Right.
by reaction.
I don't
let's
want
say,
to get this in.
we are having deposition.
Maybe
Yeah.
not perfect, very simple.
Because you have to just ask him to be sure, like.
Just put it till it comes to contact.
I see.
You are not,
Yeah, it's under
100%.
And obviously, crystallized is more ideal, right? If it's
Yeah.
amorphous, it's like a. I know in solar cells it's like just a lower efficiency. That's the.
I'm gonna check and see if we have any
So
application notes
now
on that.
it's in contact, but I didn't make a very high pressure. You see,
It's not flushed yet.
Yeah, yeah. So that's good. Let's run like this, and then do you mind if we try with the high pressure? I mean, you might want. It's up to you. It's up to you.
Okay, for the sample, I don't care. I have a lot of samples, but I don't want to make any damage for the crystal itself. So maybe
It
the
shouldn't damage the crystal.
On the ATR?
Yeah. Like.
Oh
push
no,
it-
it's a diamond crystal. It's fine.
Yeah, it's
it's
diamond.
fine.
That's fine.
We can try that right now and make more pressure.
Sample scan.
It's time.
Are you going to have different thicknesses?
Yes, that's why I was thinking the silicon wafer should be a kind of transparent for infrared emissions, because most people actually report a very good profile for the vanadium dioxide coated in silicon wafer under the FTIR. So if the sample is opaque, they will not be able to report these vanadium profiles. Okay? Many people do that. That's why I'm asking about it. And actually I've ordered the same silicon wafers actually recommended by these people. So I'm using the same type of silicon wafer. That's why I'm now kind of confused why it's opaque here and then it worked. So I have to think about it again, because I was expecting that silicon wafer should be a kind of transparent for specific wavelengths. Okay? It should be, yes, kind of opaque, not like this reference sample. But I was expecting to see some kind of pattern.
Right, right. Well, it might
And
be
the surface,
something.
I'm sorry, go ahead.
It might be something where you just might need lots of scans. If you only have a very small amount getting through, and then it just takes a lot of scans over each other to build out the signal versus the noise.
So now here's the machine. I know all the parameters work. play with it and see how it works. So
Yeah,
I spent some time actually here doing it. So if you can get a nice profile.
Do you know from literature where you would expect to see?
Yes, I have the profile. I have the profile of the silicon wafer itself and the profile of the medium dioxide in the total silicon wafer.
I see.
So I know.
Yeah. Well, that's good. Good starting point. Alright, 7 more seconds. 5 more seconds.
Also goes around 300%, means that it's a kind of lot of reflections coming here.
And just to confirm, the wafer's down, right?
Both sides
Not
are
all the
same.
way.
Oh, both sides. Okay, good,
Yes.
good.
It's, yeah, but the torque is not torqued all the way.
No, it's not totally.
Okay, that's why I was like, why does it? We're barely reading anything. Okay, yeah. Can we twerk it all the way? Like,
Yeah.
I'm not afraid for the diamond crystal. It's gonna be fine.
More pressure?
Nope. Keep going, because it should click. Yep, there it is. Mm-hmm.
So this would be a good experiment for you to see with your hand
Yes.
tightening versus all the way.
Actually, I was afraid actually to push
So I'm like, don't be afraid about it.
I know the feeling. Get a new instrument.
That's how we do diamond crystals. I know you and I had a conversation. What was it? Wasn't you and I? But the germanium crystal, that one's soft. Like I would be worried if you had the germanium crystal, but with the diamond, it's fine. Yeah.
And the reason people would use different crystals is because of different absorbances and like different ranges, right? So,
Mhm.
so some things you need that germanium crystal versus.
But I think the
It also
diamond is
costs.
a common one, the diamond actually. Most people
It is.
use it, right?
Yeah.
I know.
And I am interested in your paper. Like right now, we're running 30 scans. Typically, the average is about 45. But with something like this, I'm assuming you're probably running about 120 scans, right?
Not quite sure.
Okay.
They only reported that they didn't use the FTIR and they reported the silicon profile and they reported the medium dioxide profile. So they can measure the subtraction, not the silicon profile.
Mhm.
So this is how they reported during the paper. So that's why I'm trying to repeat what they have.
Yeah.
Well, more scans will give you more signal because the signal should be in every scan, but the noise will be kind of variant between different scans, so they won't add up as fast as the signal will. And so then, the more scans you have, that's why your signal
Should be much more strong.
should be strong. Exactly.
Have I sent you an application note? I wonder how many scans we did in the application note that I sent over to you. Do you remember the application note that I sent over to you?
I remember.
Yeah.
I think we have the number of scans.
All right, so we have finished our measurement. Which one is this? So this guy. Silicone wafer
Silicon wafer test, yes.
test on.
It should be the raster.
Yeah. Well, and you can tell it's old, right?
Yes.
So if we click on any other, so you can tell there's this one. All right. So let's see. Do
So
a-
this is given by the way. This is
Oh, hi.
No.
No, I'm Joy.
Joy.
I'm this.
Not-
Oh, Joy. Yeah. Are you ready?
Yes.
Oh, nice to meet you. I know, lots of phone conversations. Nice to finally be in person. Yes.
Yeah, it's not giving me good. Yeah.
Never gets signal.
So what does it mean? It says 100% here transmitted. Means that the sample is 100% transmitted, or it's not an indication for this because it says 100%, right?
Yeah.
The amount of transmitted, in fact, should be 100%. Means that all this range is transmitting all this wave number and only transmitting around 90% of this range. I'm just trying to understand the
Sorry.
data.
Yeah. I
Or
believe.
maybe it's a kind of force data because it's a big sample.
I believe it's no transmittance here because with IR, as it dips, like this is showing that
It means there's no stretches.
Yeah.
But what I want to do is we actually need to
In terms of recording history.
we actually need to increase this a lot. This too.
So 100 means it's not transmitted through.
Exactly. There's not exactly.
Oh, okay.
Nothing exactly. Nothing.
So 0 means that it's fully transmitted through. 0%.
So,
Seems confusing.
It looks like there's a reverse. The logic is reverse
I
because
don't understand. It means that when you say 40% transmittance, means that 40% of the radiation being transmitted and 60 being absorbed. Right? So this is how I can understand the reference. So the scale is from 0 to 100. When I see a profile, so in specific wavelengths, I just say that it's around 40% being transmitted. So it means that 40% transmitted and 60 being absorbed.
Do you mind moving the wafer? I need to do a new background scan.
It's the other way around. If this, what this is showing here, is that bond. Let's call it a CC bond, carbon-carbon bond. If the wavelength, the energy of the wavelength matches the wavelength of the stretch, then the stretch will absorb it.
okay.
But only if it matches. If it doesn't match, this would be gone, and it would just look like this. So that's why it seems strange when you look at it, right? But if you see that the line is flat and it's not doing a dip, I mean
It's not matching anything.
It's not matching any of the bonding. I'd guess I'd say this is probably like a carbon dioxide.
All right, let's pop on the sample. Because you have something like this, you don't really need to clean the ATR or anything, but say that you guys did move over to powders or something, just make sure that you're cleaning the surface of the ATR in between runs.
It was actually IPA was acetone.
IPA and a chem wipe. And don't spray it directly on the crystal. Put it on the chem wipe and then exactly.
Gotcha.
Exactly. And so all I did here was I increased it to 100 scans and I changed the resolution to 4.
More scan and better resolution. More scan and less so.
And less resolution. So again, I'm just playing around with it. Yeah, exactly. Because it goes all the way down. So before we were running at 2, but if you look at the, oh, I can't click it now because it's running. Yeah, but it goes down to like 0.25.
25, yeah.
Yes.
Mhm.
That'd be a table. That table. Hunting for it.
And once you get into like still playing around with it, if you have more questions and it's outside of the scope of what Andrew and I can handle, again, we have those specialized product groups that I can point you to those people, and they're spectroscopists, and they can guide you exactly.
Yeah. There it is. There's a table that shows.
This is the maximum resolution, right?
Yes. Yep. And it's in section 4.3.1 of the manual. Actually, that's why.
So I wanted to do at 4 and then drop it down to 0.25. So just so we can see the differences in the resolution.
I'm not sure if it's going to let us while we're doing this, but the only tabs we haven't looked at are this more and this advanced tab. So let's see. Actually,
The interferogram?
interferogram, thank you. That's what the IFG is.
Yeah, all of that. You can't edit anything in those. You really can't edit much in those tabs anyway.
Okay.
So let's go back and run it again. And then just change that resolution to
Where is it?
There you go. Yep.
All right, let's all take lunch now. And so instead of setting the aperture, that's because we changed this resolution. So because we're sending through more or less light.
You have to make a background check with the same position.
Ah. All right, fair enough.
Okay.
I'm sorry behind it. You're working so hard.
Sorry for staring into your camera. Turn around a little bit.
So it will take 30 minutes. 30 minutes?
Yep. 30 minutes. That's what I said. These scans are going to be kind of long just because, again, how sensitive we need it to be. Yeah. Yeah.
So I was kind of joking, but maybe it is a good time to take a lunch.
Yes, no problem.